Okay, everyone. This evening we're going to be continuing our study session on R for data science, the book R for data science. In this study session, I'm going to be going through data importing. So last study session I went through workflow, scripts, and projects. So this section is going to be talking about how we could import our data, how we could import our data into R, and also make use of that particular data. So first of all, we need to load our tidyverse package as usual, which actually contains the readr package. So the readr package is a package that is usually used for loading or importing data into R and work with that particular data. So we have to make sure we already load our tidyverse package, and this is it. And also we're going to be reading the data now. So this is a sample CSV file, as you can see, comma separated value. So the first row is usually the headers or the column names or titles, and they're separated by commas. As you can see, they are separated by commas. So these are the ID, the name, the favorite food, the meal plan, and also the age. Each is separated by commas. So this is what we call a comma separated value. One of the simplest file formats for that one can actually work with in R. And this is just a simple example. So you can also now see this comma separated values, how it looks like when converted into a data frame, maybe in R. You can see the student ID. We also have the full name and other columns. So we also have tab separated values, usually separated by tab. We also have TSV. Yes, TSV. And we also have other separators that one can have in a file, but it most common is usually the comma separated value. We can also read file into R using the read CSV. So if you want to read this CSV now, we can read it in R using the CSV. So the first argument is the most important. You have to give in the path to the file. And this path is actually the path in your directory where this file is actually saved. Okay, so I think, let me just create an R project to make things easy. Or maybe I can just use my desktop directory. The desktop. Okay, this is the desktop. Okay, so now this is just an example. Now we're already using the read CSV function to load the student.csv file. Just an example CSV file, student.csv into student. I'm going to load. So I actually have a CSV here. This is the CSV. This is the name of the CSV. This is the CSV. So I'm going to just load this just to demonstrate an example. Let me just call it student. It's also a student's data read CSV. Let me just copy the name. Okay, so let's just load this and devices students. Right. Okay, it's also bit.csv. Oh, what's happening? Okay, desktop. I think this is on my desktop. Okay, so it's actually my desktop. I think it should go by. Okay, so now I've already loaded the data already. So I don't know. Students. Oh, I actually thought I'm on Python. Okay. Okay, so this is it. I've already loaded the CSV. So this is just a CSV. And when you go and look at the raw file now, if I should go for the raw file, I don't know if the raw file can open here. View file. Okay, I'm actually going to have. Okay, though the raw file, when you see it, it's just going to appear something like this. So just with commas, commas, commas. So I don't think we need this. Okay. Cancel. Okay. So that's it for the CSV file. So there they're giving us a practical advice that once you read data in, the first step usually involves transforming it some way to make it easier to work with in the rest of your analysis. So now let's take a look at the students' data in the mind. So in the favorite.food column, there are a bunch of food items with the character NA, which should have been a real NA that R will recognize. So R can't recognize this NA. So they're just telling us that it should be N instead of N/NA, that R will recognize as not available, because once it's NA, R is going to recognize it as something that is not actually available. So we can actually address this using the NA argument. So where is the file? So this is, we can have the NA argument. So NA argument. So this is something that we can address. So which means anytime we have N/A and empty, or we have something like this, just an empty cell, and you should take that particular cell as a missing value that is not available value. So this is what I'm just trying to tell R to recognize. Instead of just loading data like that, we should use this particular NA argument. And also, you're telling us that the student ID and full name columns are surrounded by backticks. So this is the student ID that's surrounded by backticks. And the reason why is because of this space that is here. So we don't want it to break. You should not actually, because in R's rule, we cannot have a space in a variable name or a variable ID. And we know a column is actually sort of a variable in a data frame. So we don't actually want that to break R's rule. So that's why we're using the backticks. So anytime you have column names, usually with space, you use the backticks. They are called non-syntactic names. So this is it. Even if we want to refer to them inside functions, you use the backticks just to make sure that you allow R to recognize it as a whole character without any space in between. And also we have an approach called Janitor. Janitor is a package. So let me install it. I don't even have it. So Janitor is the name of the package that we're going to use also to clean names. So it's also another alternative. So when you use Janitor now, instead of manually cleaning it yourself or maybe performing some manually cleaning it yourself, you can actually use this particular Janitor package that just they did here now. They use it to clean the column names. So it's actually used to clean the column names. So you can see Janitor clean names. So instead of student ID with a space earlier on, we have an underscore. Also the same thing if you check this, I think is it favorite.food. Okay, student names, student ID, favorite food. What is it? Okay, I say okay, we're not actually using their data, so I think that's why. But this Janitor, more or less, it just converts in your column names into proper variable names. You can see the student ID here was having space. I think this is it. It's actually having space. See it here with the full name with the backtick. So you can see what is already converted into using the Janitor package. And another common task after reading data is to consider variable types. For example, meal plan is categorical variable with a known set of possible values. So we have meal plan, which is actually categorical variable. So instead of it to be a character, I want it to be a categorical variable. So she is represented as a factor. So which means a factor with just two categories, lunch only and breakfast. I think we have lunch only and breakfast and lunch. I don't know if we have other factors too also. So if these are the only factors we have, let's say 2, then it's going to be recognized as a categorical column, not just an ordinary character column. So we can use the Janitor clean names and also apply the mutate function to turn this particular column into a factor or categorical column. So the only thing that changed was this factor from character, which was character in this place, it changed towards factor. This is very important when you're conducting analysis that deals with categorical values. Okay, the next is we have students, janitor, clean names. We have we also want to fix the each column. I think that's what we're trying to do in this place. We're trying to fix the each column, which is actually a character variable. I think if you come here, the age is actually a character variable. So because of these particular values here, 5 and NE. So it has already converted all the other numbers also to character, which we want to try and create in this place. So that's what we did in this place. We are going to pass number. We are using the mail plan, which is a factor. Already done the mail plan. And next is to use the pass number. So with this pass number, we're going to check if the value is 5, it should convert it to 5. Else, it should stay as the age. So this cleaning we are doing is just peculiar to this 5. So this function, the if-else function, is going to iterate through this age column. And for each value, if the value is written as 5 in words, then it's going to convert it to 5 in numbers. Else, it's going to stay as the number. It's going to stay just as the number it is, just as it was before. So if it goes through 4 and find out that 4 is actually written as 5 in words, it's going to replace it with 5. But since it's just 4 in numeric, it's going to keep it as it is. So this is what is just if-else function is just trying to do. And pass number means that we're going to convert the whole of this column from character to what? A double. So it's not going to be a character as it was before, it's going to be a double. So this is just some basic data cleaning that we're doing in this particular place. We have other arguments too when reading CSV files. We have this is just a simple CSV file now. We can just load this. This is a simple example. You can see it A, B, C are the columns, and we have 2 rows. So usually read CSV uses the first line of the data for the column names, which is a very common convention, but it's not uncommon for a few lines of metadata to be included at the top of the file. So you can use skip is equals to n to skip the first n lines, or use comments to drop all lines that start with, for example. Look at this now. This is a CSV file, which we have here. So this is a CSV file. We have the first line of metadata, the second line of metadata, of XYZ. So now this skip command is going to make sure that this first 2 lines are skipped, so that this will only come out as our data. That's what we are trying to explain in this particular section. So we just want only these 2 to come out as our data, skipping this and this. And also, if you want to add a comment to also, you can also, instead of using, if you don't use skip, you can use comment to signify. You can use the comment argument. Is equal to hash. So what do you use as your comment? Was it hash? Then you now say comment is equal to hash to signify to the read CSV function that you're actually loading the XY, the last 2 columns, but the first one or any character or sentence starting with an hash is actually a comment. So this is going to load just this particular part as a CSV. So in other cases, the data might not have column names. You can use column names equals to false to tell the read CSV not to treat the first row as headings. In some situations, the data might not have headings or column names. So you just want to tell it that there is no column names. So column names is equals to false. It's going to be an argument to tell read CSV not to treat the first row as headings and instead label them sequentially from X1 to Xn. So its column is equals to 4. So it's going to treat first and instead you're going to label them sequentially from X1 to Xn. You can see it's already labeled them from X1 to Xn. So I think if we load this here. Come back. Okay, so this is x1, x2, xn. So this is what's happening here. Because you don't have column names, it's automatically what's saving them up to the xn. So xn is the number that is at the last. So if I have, for example, 8 here, and I have, for example, 7 here, and I load this. So we have also x4. And alternatively, you can pass column names yourself. If your data doesn't have column names, you can also use the column names argument to pass column names. As you can see, we have here. I can just add in this argument instead of column names equals to false. I just use this and add another extra because I'm having 4 columns. And you see, I'm going to have these column names already given. So these are some extra arguments. You can actually use the question mark command to check for other arguments, which the read CSV function also has. So we have other file types. We have read CSV2, which reads semicolon separated files. This is also another CS type of semicolon separated files. We have TSV for tab delimited files. So files that are separated by tab instead of a comma. We have read delim. This one is separated by a delimiter. So now a delimiter is actually just more or less like a separator. So in this function, you actually have to specify the delimiter. This delimiter can actually be a CSV because you can also use this to read a CSV. That is a comma. Your delimiter can be a comma or a tab like this or a semicolon. So this function is more or less like a universal function. You can also load the CSV file for you. We have read FWF, which reads fixed width files and specify fields by their widths or by their positions. We have read table, which reads a common variation of fixed width files where columns are separated by white space. And we have read log, read Apache style log files. So this one read log files. So these are the various file types that we have. Also, we have some exercises. Let's go through it. So what function will you use to read a file where fields were separated with? I don't know what this sign is usually called. Okay, so what function we want to use to say we actually separate this particular sign with? So earlier on we talked about read delimiter. So we actually use to specify delimiter. So you more or less just use this read delim to actually read any data separated by this. The next one is apart from file, skip, and comment. What other arguments do read and read CSV function have in common? So we can actually check for this. We just use the read CSV. So I think we have the read CSV, we have the arguments here. Okay. So we'll just check through it and just compare it also. Okay, so this more or less, they are more or less under the read delim. So they more or less have like, okay, this is the read CSV. So this is for the read CSV, and this is for the read TSV. So for the read TSV and read, I think, okay, they say read TSV, right? Okay. File, skip, and comments. What other arguments? I think column names, column types. Yeah, column name, column types, column selects, and we have n marks. We have quoted NA quotes. Also, have quoted NA. So this is just where you can see some of the differences and similarities between them. So those are some of the arguments that they actually have in common. So what are the most important arguments to read FWF? We need to check this also. So what are the most important arguments to read FWF? I think we have 5. We have column position, we have column types, we have column select, we have the ID, we have the locator, and these are the discussions about this particular function also. So if you want to use it, these are the explanation of the arguments. The fourth question says, sometimes strings in a CSV files contain commas. To prevent them from causing problems, they need to be surrounded by a quoting character, like or by default, like or. So by default, read CSV assumes that the quoting character will be a double apostrophe. So read the following text into a data frame. What argument to read CSV do you need to specify? So, so to prevent them from causing problems, we'll go to by quoting character. So what arguments to read CSV do you need to specify to read this particular file? So these are our commas here, these are commas here, these are commas here. So I don't know. A comma B.
Mọ̀tàrà ṣé mo ti ń fi Ibrahim ṣe yẹ̀yẹ́ mo ní òun tẹ rí ní náà mo ní òun tẹ ní rìgáàdì fún ọ ó ní kí dákun ṣe fòwúlẹ̀ nǹkan tí wọ́n bá affect mi mo ní ìgbó èmi ní affect àbí wọ.
Can you mute your mic, please? I'm hearing you, Mr. Victor. Yeah, you can speak.
I think we have a question from Victor.
Yeah.
Do you want to, or contribution?
Yeah, we can. I'm listening to you, Mr. Victor.
Sorry, you said?
Yeah, he raised up his hand, so I'm saying if you can. I'm not hearing.
Okay.
You.
Okay, should he go ahead?
Yes, he should go ahead.
Okay, thank you. Victor, you can go ahead. Sorry, we can't hear you.
Is he mute? I think he's mute.
No, he's not muted.
Okay. Okay, let me just continue then.
Okay, go ahead.
Okay, I think let me switch to another system. I need to leave this. Okay, please give me. Okay, so this question number 4 says sometimes string in a CSV file contains commas. To prevent them from causing problems, they need to be surrounded by a quoting character like or by default. So read CSV assumes that the quoting character will be a quotation mark. So to read the following text into a data frame, what argument to read CSV do we need to specify? So let's check So let's just check the help command. We'll check the read CSV function. I think, okay, because I don't have this installed. Okay. So read CSV. Okay, I don't know. How's happening? Read CSV. The help command is not coming. Okay, let me install the tidyverse package. Maybe we can search for it. I don't know. Okay, sorry, please. Why? Let us. It's why it's installing so that we can check the read CSV function. So if we look at this now, we can see quotation mark at the beginning, and we can also see quotation marks at the end. And you can see A, comma B actually have quotation mark, single quotation mark, while at the outside we have double quotation mark. So trying to function that will let us be able to read this in without encountering any problem. So let's go to the read CSV function and see. I don't know why its app is not coming out. Okay. I think this is the function quote should be. Let me check. Let's check the quotes NA and quotes. So quoted NA, we have quoted NA. We have quotes and quotes NA. So actually looking for the quotes. Let's see if we can get the quotes. Let's see the quoted NA. Oh. So it should be between these two arguments, the quotes and the quoted NA. So let me copy it and read it. So we're going to say read. Over. So read CSV and we'll paste this. So this is it. So let's run this. Let's see. So error could not find function read CSV. Let me load the library tidyverse. So I think you guys can see the problem here. So it's actually giving us only two values, 1 and A, comma B. So I think we need to specify quotes. Then we now use the argument quotes, which is equals to, so I think by default the quote should be, let me try this. Okay, still. I'm trying to see explanation of these arguments here and I don't know. Okay, this is it. Single character used to quote strings. This is what it's trying to, this is it. Single character used to quote strings. Okay, let's try the slash and see. Okay. We're supposed to have x, y slash n, y1 and a comma b instead of just 1 and a comma b. So they say the quote is actually a single character that is used to quote strings. Okay, I don't know. Does anybody have a suggestion on the right way of using these arguments, or if we're using the right arguments, and if it is the right argument, how should we use it? Because look at it now, we have 3 comma, okay, we have x, then we have y/n1 and y/n1, and we have a comma b. So, but this, which means you'll be having 3 elements in a row, and a comma b should be taken as 1 because they already have quotes surrounding them. And when we load this directly, we're having 1 comma a comma b. If we are to load it, we're having 1, then a comma b, x and y. Okay, I think I know what the problem is. I think I know what the issue is. So
Okay.
this x, this slash is actually a way of signifying a new line. I think that's what happened. So if I should remove this, or let me just copy this line and oh, what am I doing? My fingers are big. Okay, so if I should remove this, I don't know. This should be what we're having. I don't know. Let me just see the previous ones we have done. Yes, that's what we are having. Okay, so if you look at this, they are about the same thing. So this is just, this slash and n is just a way of signifying a new line. So that is 1. And number 2, to signify these codes, we need to use, I think we are going to use this particular code argument, because based on what they say there, they say the code argument, single character that is used to code strings. So a single character that is used to code strings, but I'm seeing a slash in this place, and that is what's surprising me. So, okay, let me just comment this out since we already understand that, and let's run it again. So we have a comma b, and this is actually the default. So this quote is this, what it is here is the default. Okay, so let me now try quotes. This equals to, let me try this and see what's going to happen. Aha. So now, this is the argument we are going to use to signify a quote. And we don't want that quote to appear inside the data.
Hello?
Yeah, I'm hearing you.
Hello?
Hello, Mr. Yeah, I'm hearing you.
Okay. I think this in line 4, right? Or no, let me say line 3, the one you commented out.
Yeah.
What we have here is just the exercise is giving you a typical CSV format where you have a header.
Okay.
So the x comma y is the header.
Okay.
And then the second line, which is after the backward slash n,
okay,
is the second line of the file, which has 2 elements, which is the 1, comma. Then what you have here now is the string, and the string is quoted with single quotes. So this entire string a comma b is one element, one element which will come under the y. So the a, so this is just a string a comma b, which is under the y column. That's what happened here. So for the quote arguments, that you're trying to use here in reset in line 4. According to the help file, it says you should give a single character which is used to denote, or which is used to quote a string. So in this case, what is used to quote a string is the single, that's the single quotation mark, which is the one before the A and the one after the B. So that's what is used to quote this string. Because without this quote, then this CSV file will not be properly read because you have a comma between the A and the B. So the comma will actually be interpreted as assertive, which is denoting a field rather than the two being together in a string.
Okay.
I think that's what the exercise is trying to show us.
Okay, so that's correct. Thank you very much. Yeah. So in summary now, I think we just use the quote anytime we want to escape a particular value, a particular character using to quote a value. It can be a single apostrophe or double. You actually use the quote argument and you use this slash as a sign of escaping it. So that means when it comes across that, then you should not take it as you should take it as a quote. I mean, so it's going to take it as a quote. So that's what this is.
But I want to ask, without this backslash, it won't work. Is that what's happening?
Let's try that and see. I don't know. It's actually going to work. So
okay, it should work.
So both with it and without it is going to work. So yeah. Okay, thank you very much, Mr. Victor. Okay, I think number 5 is saying we should identify what is wrong with each of the following inline CSV files and what.
I'm sorry to interrupt. You know, I asked the question before, but my thing was misbehaving, so I didn't hear if there was any answer.
Okay.
What is a fixed width file? I need some explanation of that.
Okay, fixed width. Okay, I think earlier on we were talking about read F something. I don't know.
Yes, exactly. I didn't understand the definition of a fixed width file. I need some guidance on that.
I don't know if anyone could help us here, but I don't know from based of what's my own understanding. I think actually be the space between values in a file. So just like, because I think though that's what I understand it as, a fixed width file should actually have a fixed width between each values in a file. So just like we use a tab to separate the tab delimited files, because in a tab delimited files now, if you use a space instead of a tab, because a tab at times is two space bar. A tab is 2 space bar, and let's say we have a space inside it. So it's more or less going to regard that maybe as a single value, as either by putting quotes or not putting quotes in it. So I think a fixed width file should actually have values that are separated by equal widths. So that's what I feel like the fixed width file actually means. Because I've never worked with something like that before, but I don't know if anyone else in the house has any idea on what the fixed width file is.
Can I make a slight correction to what you just said? You said that that the fixed, so a tab is 2 spaces, or tabs limited files are fields separated by 2 spaces, or by, the tab is not actually 2 spaces.
Okay, is that space?
Yes, actually there's actually a tab character, which is a part of the ASCII character sets.
Okay.
Which in R it is represented with a \T. That is the tab character.
Yeah, it's true.
So when you enter tab, it's \T, which in some cases it is 2 spaces depending on the setting that you use. Sometimes it may be 4 spaces, but it can be 8 depending on how you set it. But the tab itself is its own character.
Okay.
So I tried to just do some research on the fixed width file. Let me just share what I found, just for our knowledge.
Okay.
So the fixed width file is a type of text file where each column of data occupies a specific number of characters the data in each column is aligned to a fixed width. Okay, I understand now. Meaning that the length of the data in each column is constant across all rows. So a fixed width is that when you have each item, let's say if it's in let's say it's a column, right? Each item in that column has exactly the same width. So if it's, let's say, a number, let's say like now 1,000 has 4 characters, 1000, right? 4 digits. So every a corresponding data element in that particular field must have the same width. So that's what is more. I saw here, yes. So that's what it is.
So if we have a string of 5 characters, then every other row columns
must be 5. Yes, something like that. Yes.
Okay, thank you very much. I think that's clear. Also, I also learned something. Okay, I think we can move on.
Thank you so much. Thank you.
Okay, we have 5 commands here to read CSV, and we're asked to ask what happens if we run each code. So I think we should just copy it, and we should copy it and see. Okay, so I think we just start with the first one. So the first one actually is running. So let's see if, okay, there's a problem in this one actually. So 2 and 3 shouldn't be together. Also 5 and 6 shouldn't be together.
It's interesting.
Okay, we're having three columns for the values, but the column names or the headers is just 2. So I think that's the problem with this. So if
it's not only that stuff.
Yeah.
It's not only that stuff.
Okay, what else?
The interesting thing here also is that this function read_CSV has done a type inference. So okay. It has already assigned. It has turned these numbers into double. You see that table there.
Yeah.
That's a double. So that's why you have instead of the thing failing, ordinarily the thing ought to fail. But instead of failing, it has done its own type conversion and assumed that these 2 and 3 are together, and it dropped the comma and gave you 23, which is very interesting.
Okay.
I'm
well,
sure
me, I actually think.
I'm sure it will definitely now align properly.
Yes, that's what I'm trying to say earlier on, that we have 3 values, but we're only having 2 column headers. So that's what I'm trying to say, that should be the problem. But okay, so what's actually run this? Okay, so it's already fixed now. So I think we are done with that one. We had CD. Okay, so we have the next one also, read CSV. We have A, B, C, and 1, 2. Okay, yet also I've already seen another problem. The headers is 3, but the next row is 2 values, while the last row is 4 values. So this is also the problem in this.
No, but right.
No, we need to move
it's
the backslash and N.
This particular 3 and 4 are not supposed to be
together.
To
move it.
So it's either we add.
Yeah, you have to add D.
We can move. Let's move the backslash N after.
No.
After
no, I disagree, because you have to actually look. If you look at this, you have to try and deduce the intention here. The intention here, I think, is to have 4 columns.
Yes.
Because the third row has 4 different items.
Exactly.
So what we actually need to do here is to even add a D, and then the other ones will not be NA on the second row.
Exactly.
No, we're adding a no. I don't think so.
Let's try
Okay.
first.
No, why don't you try? Well, it's supposed to be 3 columns. I think we want to achieve the same thing as what we have on line 8.
Okay, I
So
think I
that
understand what she's pointing.
backslash.
I
Is
understand
that
what
the
you're
intention?
pointing.
Is that the
Yes,
intention?
we're going to, I
Yeah.
think I understand what she's getting at. This backslash, we'll move it like
Exactly.
this. Then
Put
we
comma
now,
there, then remove that comma, remove the comma, then
like this.
backslash n.
No, but
Mhm.
no.
Let's try that.
No.
Yeah,
No, what I'm
that's
saying.
it.
Okay, I think we have 2 ways of actually solving this. We can actually solve it the way Mr. Victor said earlier on.
What's the question? What's the question in the exercise?
No,
first?
he's just trying to tell us to, let me see the question.
What are we to do? So that's what will determine what should be done.
Identify what is wrong with each of the following inline CSVs. What happens when you run the code?
So what is wrong in each of the following? So
The
like
code
I
is
was saying,
it's not actually failing when we run it.
yes.
So
like I was saying, by moving this new line, we are completely distorting the entire thing that has been going on here. You know, like I said initially, if I look at it, what was the intention here? It looks more like the intention here was to have on the second line to have 1, 2, 3, 4 as separate fields. But I don't know if you can do, just go back to the previous thing so that I can explain what I mean.
I think this is what we have.
Yes, we have something like this, right? So if you at first glance, if you look at it, you see that since the second line has 4 fields, if you move any of these new lines, you're completely distorting the entire structure. So I think that the intention here is that there should be four columns, but we have only 3 columns mentioned here in the header. We have only 2 columns, which means that that they are missing values. That's in the first row. This is the way I look at it too.
Yeah, that was what I'm saying. It's somehow subjective. We can either do it the way you said earlier on. It's also correct, and also the way she said it earlier on to also. It's not another way of the issue. So it's subjective. So, but all is still the same way. We can let's just try to say it.
But if we do it the way Cookies said we should do it, the data have changed entirely.
Yeah, it's true. But let's take it like the data is not actually. Let's just take it like
important.
It's another problem. Okay. Let's take it as as a problem which we can solve 2 ways. I think that's what the way I want us to take it like that. So let's just forget about data and take it as a problem we can solve 2 ways. So we already know that each of these particular rows should have the equal number of values. I think that was what she was trying to point at, and also the same thing also trying to point out that we should increase another column name, that is by adding T to that place. So we just take it as a problem with 2 ways of solving it. So I think that's
run this one. Let's see it. This line. Let's see how it is. Okay, that's it down there now. 1, 2,
yeah, that's
okay.
it. So that's it.
Okay.
So I think this is what I explained earlier on. So we just take it as, so we know that those other ones is declared as NA. We have 2 NA in the second in the first row. Okay, so for this other one now.
Okay. Awesome.
Okay, for this other one now, let's run it and see what the problem is. This one did not even bring any. So the problem with this is that, okay, I don't know, can anybody help us?
There's a backslash here that's causing problems. After the backslash end, there's another backslash. So it is escaping the quotation marks entirely.
Okay. So I going to remove it.
Yeah, just try to remove it. And let's
remove it.
Okay. We are getting.
If we remove.
Do you think we should?
Okay, we have another error.
Do you think we should use
remove
the quotes?
Yes, move that one. Remove that one too.
Oh, okay, okay.
That quotation mark, the one before the one. The one before the one.
And remove the
Yes,
backslash also?
Yes, the two of them. Move two of them.
Okay.
Move the backslash.
So we're left with this. So
Yes.
do you think this is the solution to it? Okay, let me look at it another way also. I'm trying to see. I'm trying to see another way. Okay, well, I guess that's it then. I don't think there's any other thing. Okay, let's look at the fourth one. So what's the problem here now? AB, 1, 2, AB. Is there a problem here? I don't think so.
I can't see anything.
You can't?
I can't see any problem here. The only thing is that let's see what this function will do. The only thing is that I can see that the types are different. We have numbers and this thing, but we don't know whether it will interpret this thing as a string or as a number. But
It's already coerced. I think it is already coerced.
So exactly. Yeah, so that's it. So it works.
I don't think that's the problem here. Then the last one, I think there's a problem here. Yeah, this one, I think the problem is even direct. Can anyone help us out?
It's I think it's semicolon. Semicolon.
Semicolon.
So I think we should use this then.
Read CSV2.
Okay, well, we can use CSV2 also.
Yes, read CSV2 also work.
He has a, what do we use to specify the delimiter? We use what? What's the?
It should be delim. I think something like that.
Delim.
That's a delim.
So
it's delim.
Okay. Then let's also use read CSV2 and see. No, we need to remove this. Oh, well, okay. The bracket here is missing.
This is missing.
Okay, I think also the same thing. So we can either use read CSV2 or you can use the delim. Okay, so this is the last question saying practice referring to a non-syntactic names in the following data frame by extracting the variable called one. So they want us to use non-syntactic or to refer to non-syntactic names in the following data frame by extracting variable called one. So let's just copy this and I'll paste it here. So annoying, and then we have okay, they want us to extract the first task was to what? Extract the variable called one. So let me see, select one. That should work.
Use a string.
Okay. So I think this is it.
Can you use the double brackets, the square brackets? I mean, to extract it. Let's see.
We should try the square bracket also. Well, it's telling me one not found. I think it's the
no, use the use a string. Use a string, yes. And I think it should be double square bracket as well.
Okay.
You still have those backquotes there.
You're still telling me now.
You have to remove the backquotes. Remove the backquotes. Remove those backquotes. Inside that, then let it just be a string, a single character string. Remove the backquotes.
Okay, let me ask something.
Like
Let's see if you have something like this. Then I'm coming.
So it works.
Let me have something. If we have something like this now, let's try this and see.
It will work. It will definitely work.
Object one. Okay. Okay, I think this is what is causing problem. Oh, I'm coming. Let me just make this one to be. Okay, so now let's try it here and see. Okay, so that means we don't actually, what did the question even say? Non-syntactic names. So we don't need a backtick when using double brackets.
No.
But when we want to use tidyverse functions, we need the backtick.
Yeah, because they are unquoted.
Exactly.
It's unquoted inputs.
Okay.
Okay.
That's great. Then the next task is plot a scatter plot of 1 versus 2. So we should plot a scatter plot of what's the function to, I think it's plot, right? Plot a scatter plot. A simple scatter plot.
Plot should do it. Plot should do it.
You said it's
plot should do it.
Okay, plots.
Then plot should do it.
Annoying. Okay, so this is it. Okay, since they want us to use, I think there's an argument that specifies the x and y axis on plot, right?
Oh yes.
Because they are asking us to use. It says they want us to use the variable names.
The variable names.
Let me see this.
You can use this thing, $sign. You can use annoying $sign.
Okay. Let me even see the function itself. I'm trying to see so that anybody watching this can see the variable arguments in plots. Okay, there is the x and y axis. So I think then is the data now. The data, which argument is the data specified?
No, you know the plot function, it takes vectors as arguments. So
okay, so I'm going to yes. I think that's why I mentioned $sign earlier on. Okay.
Yes, so you can use an annoying $sign for x, annoying $sign for y, and then you know plot it.
That means we're going to use the backtick then.
Yes, you will.
Because we can't use
if you're using the $sign, you use the backtick.
Okay, so let's run this and see. Okay, the same thing. You mentioned something earlier on. You said it's going to take a vector, but it worked when we put in the data set earlier on.
Because it has a method that takes data frames, and because you had only 2 columns, it gave you. If you have multiple columns, it give you that big one that has multiple, like that plot matrix. You know, if you have like many columns, it give you a matrix of plots with all the different distance. Yeah, but because you had only two variables, it only gave you 1 plot.
Okay.
Yes.
That's good. Okay, so the next task is creating a new column called 3, which is 2 divided by 1. So we should create a new column called 3. So 2 divided by 1. So I think this should do it. So this should do it. Okay, so I think that's that tax. We're done with that tax. Then the last one is rename the columns to 1, 2, and 3. So we can just come in and edit the names to 1.
No, you want?
Yeah.
Hello. No, I think
Yeah,
I think the intention is for you to write some code that to make the changes. Not
Okay, we should not
manually.
it manual. Okay.
Yes, so you write something that will change it.
Okay. So I think we can actually use rename, right?
Rename. Or even ordinary names. Even names, ordinary, we do it. Names, you assign to names. Very easily do it.
Okay.
In fact, it's easier. There's even an easier function to use. Set names.
Okay.
It's even easier. Set names.
Set names.
I know if you're using this this workflow, this tidyverse workflow, you can use set names. If you want to use direct, you can just use names and then assign a vector of names to it.
Set names or names. Okay, this is
like here you can use set names.
Okay. How is it different from rename?
This is easier. This is
easier. Okay, how do you now set the names now? Is it the same way with names?
A vector of names, just like 1, 2, 3 as a vector with the C.
Okay, so
use the C function as have 1, 2, 3 as strings.
I think I'm just hearing on this function. Wow. Okay. I've never used this function. I actually used to use rename. So this is actually easier. But the thing is that will this function work if I'm just trying to change 2 random
only one
columns? 2 random columns names.
Nice. You want to pick out columns now and change the names.
Yeah, randomly. They are not close to each other.
No, you use that one. You use rename for that one.
Okay.
Use rename for that one.
Thanks. Okay. So I think we are done with this number 6 exercise. The next we have controlling column types. So we want to control. So a CSV file doesn't contain any information about the type of each variable. So whether a variable is logical, a number, or a string, we have no information. So what readr actually tries to do is to guess the type of that particular column. So now this is just a simple read CSV that we have. Now the CSV doesn't contain any information or metadata about the column types. So unlike other file types which actually load, maybe Excel file types that actually have some information about the file and the column type. So CSV, the read CSV function just guesses. So based on what it's going to see. So this is just a simple example now. We have logical column, numeric column, date, and string. So this is the guess which it did, and it was able to guess right. So the logical, we have the double column, which is the numeric. We have the date column, and also have the string column, which is the character. So, but this you only work if you have a clean data set. So the guess, if your data set is not clean, where in a numeric column, you have one string there. It's going to convert everything to a string. It uses that string to decide for the other values inside that particular column. Or where in a logical column, you have your true or false written, maybe in small letters, or maybe written as a single value. Or maybe inside your dates, you have also some of those problems too. Maybe the date wasn't written correctly, or the formatting of the date is different, where we are using year, month, and day. Then in one particular value, there was year, day, and month, or day, month, and year. So all of this is going to affect the ability of the read CSV function to guess where. We have missing values, column types, and problems. So this is a simple example now. So that the most common way column detection fails is that a column contains unexpected values and you get a character column instead of a more specific type. So just like what I was explaining earlier on. So this is an example now. All the values are numeric except for one value where we have a dot. And once you read this, you get a character. So it's going to affect all other values inside that particular column. So what do we take care of this now? So let's say we have various columns and you're not able to know, you have maybe such values there, or you have a few missing values there with this kind of dots. So one approach is to tell you that X is a numeric column. You can actually specify that your column is a numeric column so that when it fails, so that's when you are trying to load it now, or when it fails, you're able to get a warning. That's maybe the particular value that is causing that particular problem. So this is a function now called read. This is our read CSV function. We are loading the simple CSV and we are specifying the column types, where we say that column X is actually a double column. And when we load it, you see we have a warning. One or more passing issues, call problems on your data frame for details. So you call problems on your data frames to see where the problem is. Then you can now see where that particular column that is causing the problem is using the problems function. So this is really handy when you have you're dealing with a large data set where you are not able to see all the values. So you have to specify the column type of your data frame. When you specify the column type of your data frame, then you are able to now detect where the problem is in case you encounter a problem. So now we can now rectify this by specifying NA, just like we explained earlier on that NA should be taken as a dot. So anywhere there's a dot is going to be replaced with what? NA. So we have 9 column types for what you can use. We have column logical and column double. Logical values, true or false, column doubles, real numbers. We have column integer, which deals with integers. We have character, column character, which deals with strings. We have column factor, categorical characters, or categorical strings, or categorical data type. We have column date, which deals with dates, and we have date time, which deals with date time values. We have column number. So this is actually going to ignore non-numeric components and it's usually useful for currencies. So you are dealing with something like a currency value like dollar, or maybe a naira value, or euro, or pound character inside your, among which is inside your numeric data type. So you can actually use the column number to specify. And column skips a column that is not included in the results, which can be useful for speeding up reading data if one is dealing with a large CSV file. So it's also possible to override the default column by switching from lists to columns and specifying. So we want to also override the default column. Instead of using lists, you can use the columns. We want to override the default column. So let's say, look at this example now. We have our default columns and numbers. So we're going to read this another CSV and column types. So we're going to use the column. So instead of it to be a numeric, we're going to turn it into a column character using the calls function. So instead of using this lists function, which we used earlier on, then we're going to use the columns function. So we'll change it from the default, changing it from the value it was before, which is actually a number, to a character. So when you use lists, when you actually want to detect or want to tell which CSV the data type of that particular column, and you use columns function, the calls function. Now you want to change a column data type into another data type, you want to specify it into another data type, or want to coerce it into another data type. I also have the columns only, which we want to read in columns you specify. So this is only going to read in the columns you specify, the columns only. So if you say X column character that is going to read in that particular column you only specified. So which means whether the data type of those other columns is correct or not, it's not going to read it in. So reading data from multiple files, sometimes you have data from various files inside a folder, or they can also form a database. This data, they can be related with each other, or they might even be the same, they might have the same columns. So you can actually use the read CSV function also by combining all those, by concatenating the files together. So you can see using the C function, and you now load it using the read CSV. It's going to load all of them together. So in this situation, these files are sharing the same column names. So they're both sharing the same column names. So that's why it's able to turn everything together into a single data frame. So I think that's also the same thing here also. Okay, I think this one is also from a link. This is also from a link. It's also explaining the same. It's also explaining the same thing earlier on. The ID argument adds a new column called file to the resulting data frame, which identifies the file the data come from. So this ID is just a way of signifying each row inside the CSV, where each particular row is coming from, the file each row is actually coming from, since we've already combined them into a single data frame. And here they're explaining that if we have many files to read in, it can get cumbersome to write out their names as a list. So let's say you are dealing with 100 files inside a folder. So you can just use the list.files function and specify the name, the list.file functions. Then you specify data, then the pattern. That is what the files are starting with in case there are other files you are not interested in that folder. So sales.csv. And this is actually a regex pattern. And we have full.names is equals to true. So we have sales files. So these are all the files. So under the data folder, which are interested in, then we have sales files. So this is going to make sure to carry every sales file that you have, sales.csv that you have. Okay, so we have writing to a file. This is just exporting to a file, and it's just as simple as using the write CSV function. If you are dealing with CSV files, you want to export as a CSV file. The first argument is going to be the name of your variable, your data frame. The second argument is going to be the file name you want it to be stored at on your local PC system. So student.csv is what is going to be saved at, and write CSV, which is students. So if we also run this, for example, now we get student.csv inside our project directory. And you can also read that particular file back in. This is how you can export a data or a variable or a data frame. You can export it into CSV. So they're talking about some of the drawbacks of using a CSV. So now they say, now let's read that CSV back, and you now note that the variable type information that I just set up is lost. Look at the variable types information that we set up earlier on. You have factor in this place, but now as you read it back, we are not having factor, we're having character. But this is one of the reasons why CSV is not reliable. So that's why we have write RDS. We have an RDS file and read RDS. These are wrappers around base functions, which you can use to export R objects. So this ensures it keeps all your it keeps your data type intact. It doesn't change it when you load it in. So in case you filter the data sets and you created a column as a factor, for example, another column as a date, then when you're reading it in, if you expect it using an RDS file and you read it in, it's going to keep all those information intact without destructuring it. So you can see here an example here. We have write RDS, we have write RDS, and we have read RDS to read the RDS file. So we also have what we call package files. It's a fast binary file format that's also shared across various programming languages. So you can use it not just only in R, you can also use it in programming languages like Python or maybe Julia. So you can also save it as a Parquet files also, and also it compresses more than a CSV. That it doesn't consume much file space like a CSV file. So this is also another way of exporting using the library Arrow. So in terms of data,
do you know about this format?
Which format? Which format?
The Parquet format. Are you familiar with it? Parquet.
Yes, I've worked with it. A particular hackathon, I think.
Yeah, it's a binary format, is it?
Yeah, it's very efficient because it's very efficient. It's saving large files. Let's say we have millions of rows. It uses less space. So a CSV saved compared the same data saved as a Parquet file compared with that of a CSV also for that particular DM data is actually bigger and even takes time to load when you're trying to load it inside maybe as a CSV, it takes time to load due to the size, unlike a Parquet file. So, though I just explained it once.
Thank you.
So you're welcome. So we have the data entry. Sometimes you need to assemble a table by hand. So this is just trying to tell us how we can create a data frame using, though R is not usually used for data entry most of the times, but a time can come, you might want to edit something inside your data that you already have. So more or less like you are using on this, use it in a spreadsheet. So this is how you can use R for data entry. Use the table command, and this table command, they're going to specify each column inside your data. So each variable that you're creating is a column, X, Y, and Z. So each of them is a column inside your data frame. If you have 5 X, Y, Z, A, B, you are going to be having 5 columns. So this is just how one can use R for data entry. And also we use the tilde. We use the tilde also to specify the column headings. So this particular character here is usually used to specify the column headings to separate it from the row values. And also this is the table function. Now, so unlike the table function, which makes how to see how the rows are related, you can use the table. So the table and table almost works similar. So transposed table. So the difference between the table and the table also is that in the table we are actually laying out the data frame column by column, but in the table we are laying it out row by row. So we have X, Y, and Z. Then we can now use this tilde to now differentiate or specify that this X, Y, and Z is actually the column, is actually the data frame headers or the column headers. And any other value following it is now the row values. So this is just the difference between the table and the table function. So just in summary, this chapter is just discussing how we can import and also export our files. Though as a reference, there are also various file types which will come across it in the future, God's willing. Or you have Excel files, we have Google Sheets. We have also files from other statistical softwares like SAS, SPSS. There are also other functions for loading those. I also have JSON files, even API files, and also there's a more discussion on Parquet files. Also, how to load API files, also data from websites. There are various ways of importing. For this chapter is more or less laying emphasis on CSV files, which is the simplest file format one can actually come across with. And so hopefully in the future we get to look at also other ways of importing other file types and also from databases, and how you can also work with databases without even need of using maybe a SQL command. So just using your R command, you can also work with databases. And the janitor package, which is also is actually not part of the tidyverse, but also gives functions for cleaning data. And also there's also another note here that I can override the default of 1000 with the guess marks argument. I think this is for the janitor package, right? Which function is this?
I think it's for one of these read CSV. I think that's something like Max under CSV, CSV.
Okay.
Maximum, the maximum number of elements to be read or something like that.
Guess Max argument. Okay, I think is there a way of loading files by batch in app? I do not.
What do you mean by loading by batch?
Let's say you have a very large file size. Let's say you have plenty rows of data and you want to load them by batch, say because to save memory, instead of loading all of them at once, you now load them by batch and work on that particular batch. And another batch is going to be loaded. You're going to work on it.
There is, but I can't remember now. There is. I remember I've come across that thing somewhere.
Okay.
It exists.
Okay, so I think this is for today's study session. Thank you very much. Thank you, Mr. Victor, for your contribution. And,
thank you very much.
Thank you.
Wonderful reading.
Thank you very much.
Okay, thank you, Ridwan. Thank you, Victor. Mohammed, thank you for joining us today. So see you next time.
Okay, have a nice day.
I have a question.
Okay.
Are we sharing the recording?
Yeah, I think it's on YouTube now. You can see it on YouTube.
Yes, the recording will always be on the YouTube channel.
Okay.
Thank you.
Thank you very much.